Hello and welcome to Maths by SAS. This is my third lesson, chapter number 1, exercise 1D, that is about the inverse proportion. How to understand direct and inverse proportion. These are the 2 points that have to be really clear to all of my students. So if you find any difficulty in understanding direct and inverse proportion, you can watch the basic lesson, for which I'll give the link of the lesson in the description box, because lessons of mathematics require continuous practice and integration with the previous lesson so that the learning becomes perfect. Let's move to today's problem. In this class, students will be learning and discussing intermediate level question 4 and 5. Question 4 says, if z is inversely proportional to cube root x, and when z is equal to 5, x equals to 64, find z when z is 216. So first of all, it's really important to understand that if z is inversely proportional to x cube, then what will be the relationship between z and cube root of x, because z inversely proportional to cube root x. So what is going to happen? Z inversely proportional to 1 over cube root of x, and z will be equal to k upon cube root of x. And now the question says that z equals to 5. Z equals to 5 when x is 64. So instead of z, what we are going to do, we have to replace 5, and instead of x, 64 cube root. Now at this stage you should have good command on the squares and cubes and square roots and cube roots. Think about the numbers whose cube is 64. So if I'm not wrong, that is 4 cube, and this cubic root can be written as 1 by 3. This goes with this. 5 equals to k upon 4, and in order to find value of k, I have to isolate k. 5 times 4 equals to k, or k equals to 20. K equals to 20. So this is the constant of variation that we are getting. So the equation connecting z and cube root x will be z equals to 20 upon cube root x. Now after getting equation connecting z and x cube root, we have to find value of z. We have to find value of z when x is 216. So what we are going to do is we have to take the same relationship, and instead of x I have to replace 216. Oh, now what's the problem with the question? 216. Now think about the number whose power 3 can give me 216 back. So if I'm not wrong, 6 6 are 36 multiplied by 6. 36, 6 3s are 18, 19, 20 and 21. So it will become 20 upon 6 cube upon 1 by 3. Okay, this goes with this. 20 upon 6, and 2 3s are and 2 10s are 10 over 3. Numerator is larger than the denominator, so must give your answer in either in decimal or in mixed number. 10 by 3, 3 3s are 9, 1, 3 whole 1 by 3. So students, you have to observe my lesson carefully, that I am not only solving the question, but I am giving you the tips how to solve question without calculator, because this is also one of the problem of the students, that they find the calculations without calculator difficult. But in your O-level examination, you will have 80 marks paper without calculator, so you should have good training of the calculations without calculator before exam. Moving to question number 5. Question 5 says, if q square is inversely proportional to p plus 3, I always advise this thing to my students to read, understand the question carefully and underline important terms of the question. If q square is inversely proportional to p plus 3 and q equals to 5 when p is equal to 2, find q when p is 17. Again, really easy question. The requirement is that we have to find the value of q when p is given, but before that we have to find the relationship between q square and p plus 3 when they are inversely proportional to each other. So let's begin the solution. Because q square is inversely proportional to what? To p plus 3. So what will happen? Q square inversely proportional to p plus 3, and then I have to remove this variation sign, proportionality sign. I have to put constant of variation and equals to p plus 3. Okay, q square equals to k over p plus 3, and there is the condition given that when q is equal to 5, when p is equal to 2, q equals to 5, p equals to 2. So instead of q, what we are going to do is we have to replace 5 k upon 2 plus 3. 5 square is 25. You should have good command on the squares and cubes and tables. 3 plus 2 is 5. I have to find value of k. Go for cross multiplication. Isolate k. Okay, 25 multiplied by 5, which is equal to k. Okay, our k equals to 25 times 5. 5 5s are 25, 5 2s are 10, and 2 12. K is 125. So the equation connecting will be q square equals to 125 by p plus 3. This is the relationship that we are getting between q square and p plus 3. Now actual requirement of the question that we have to find q. Now again you have the relationship between q square and p plus 3 with you, that is q square equals to 125 by p plus 3. Now what we have to do, that instead of p we have to find value of q. Instead of p will be replaced by what? 17 plus 3. P is equal to 17. This is given in the question. 17 plus 3, 125 by 20. And we have to find value of q, and q is having part 2 as well. So we have to try to perform the calculation without calculator. So we'll think about such two numbers in the numerator and denominator which are perfect square. Let me read the table of 5. 5 4s are 5 2s are 10, and 5 5s are. So I have q square 25 by 4. Now look that 25 and 4 both are perfect squares. Perfect squares of what number? 25, 5 square. Okay, and 5 square by 2 square, or q square equals to 5 by 2 whole square. And now I have to do the reverse process, that I have to take the square root. 1 by 2 and 5 by 2 whole square raised to power 1 by 2, and this will go, q equals to 5 by 2. Whenever we take the square root, don't forget to put plus and minus sign, and this will give me plus minus 2.5. So q equals to plus minus 2.5. While watching the lessons, please must observe the technical points that I'm discussing, that you have to focus on the calculations without calculators. For that purpose, you should have good command on squares, square roots, cubes and cube roots, and the divisibility tests as well, and the basic rules. Moving to the next question, question number 6 says that given that t inversely proportional to s cube, and copy and complete the table, that we are given with two columns s and t, one for t, 2 we do not know what's the value of t, for 4 value of t is missing, for t 0.08 the value of s is missing, and for 0.01 that is the value of t, s is missing. Okay, so what are we going to do in order to complete the table? First of all, we have to find the relationship between t and s cube when they are inversely proportional to each other. So let's begin the solution, students, and recall my previous lesson. We know in order to find the constant of variation with the help of a table, there must be one place given in the table where both the values of the two variables which are involved in the question are given. They will be helping us in finding k, the constant of variation. So in this table, very first point s1 and t equals to 80 will be used for finding k, which is the constant of variation, because t inversely proportional to what? S cube. Therefore, what is going to happen? T is equal to k over s cube. And now instead of t, what we are going to do, t equals to 80, k 1 cube. 1 cube is 1, so k equals to 80. K equals to 80. So the relationship that we are getting is t equals to 80 upon s cube. This is the equation, this is the relationship that we will be using for the completion of table. Now, the first point, t equals to 80 upon s cube. I will be replacing s by 2 cube. Now recall what is cube of 2 and what to do to get cube of 2. I have to multiply 2 by itself. 2 to the 4 to the 8 3 times. 80 by 8, sorry, this is 8 and this will become 8 ones are and 8 tens are. T equals to 10. So this was the first unknown, and let me replace the value over here. You can see, students, that I'm focusing on the calculation without calculator as well. So moving to the second part, that is t equals to 80 upon s cube, and here your value of s is 4. T equals to 80 upon s cube. 80 upon 4 cube. 4 cube is 64. 64. Now table of 8. 8 tens are, 8 eights are, 2 fives are, and 2 fours are. 5 by 4. 5 by 4. And now for 5 by 4, I hope you can easily divide 5 by 4 and get the answer 1.25. 5 by 4, keep 5 inside and 4 outside. 4 ones are, and 4 twos are 8, and 4 fives are 20. Okay, this is 1.25. 1.25. Moving to the third unknown, that is 0.08, and which is the value of t. This is t equals to 80 upon s cube. 80 upon s cube, and t, now this time we have the value of t 0.08. 80 upon s cube. Go for cross multiplication. 0.08 s cube equals to 80. or I have to find value of s. So s cube first has to be alone 80 upon 0.08. Now it's the problem to perform the calculation mentally. Okay, so let me think how to do and what to do. I hope my students know well that we can remove the decimal, multiplied by, at the top of this 8 I have 0, at the top of this 0, and at the top of decimal I have this 1. Now I am having 8,000 divided by 8 s cube, 8 ones are, and s cube 1000. Now think about the number whose cube is 1000. I hope 10. 10 multiplied by 10 multiplied by 10 s cube. So taking cube root on both sides can give me 1 by 3. This goes with this, s equals to 10. I hope you are clear about this. And now if you have good command on decimal multiplication and division and simplification, you can easily go for the solution of these all type of questions. And moving to the last unknown, that is again the value of t. Okay, this is the fourth unknown. T equals to 80 upon s cube. T has the value 0.01. 80 upon s cube. Go for cross multiplication. S cube into 0.01 equals to 80, or isolate s cube first. 80 upon 0.01. Now remove the decimal. Okay, 80 upon 0.01 multiplied by, at the top of 1 replace, put 0, at the top of 0, and at the top of decimal 1, and we are left with 8,000 upon 1 upon 1. So I'm not going to write that, and now I have to think about the number whose cube is 8. 2 cube, and I need 8,000, so 20 cube. Remove cube root, taking cube root on both sides. Okay, we have to remove cubes, so for that purpose I'm taking cube root on both sides. 3 multiplied by 1 by 3, so s is equal to 20. Okay, so the required unknown is 20. I hope students you are really clear that how we are applying the concept of inverse variations, and how we are applying the use of the perfect squares and cubes and cube roots in order to simplify our calculations. Please watch my lessons, like, share, and subscribe the channel, and press bell icon to get the notification of every lesson in time. Thank you very much.